In the lab, students took some copper powder. It is pure copper powder. There are only 100% copper atoms in here. And they placed it into an evaporating dish. And I asked students to think about, if we heat this powder up, if it will gain weight or gain mass, lose mass, or stay the same. So in order to do that, I had to get an initial mass, and it appears that the initial mass here is 49.42 grams. The reason I have it sitting on top of a beaker is because I'm going to continually heat this evaporating dish, and it's going to get warm. You don't ever want to put a very warm object onto an electronic balance. It doesn't matter that I have the mass of the evaporating dish here. We're looking at relative changes. So if the contents inside that flask or inside that evaporating dish get lighter, we will see a decrease in mass. If it gets heavier, we'll see an increase in mass, and if it stays the same, we'll see it staying the same. So students used a piece of wire gauze and a ring stand with the ring, and ignited the Bunsen burner. Place the Bunsen burner underneath the wire gauze, and I told them to stir frequently the powder. You may be able to bring the camera up a little bit to be able to see the contents of what's inside, so you can see any changes that might be taking place. You see some discoloration. Seems to be getting more of a brown instead of an orange. Ooh. It's getting darker. Trying to stir it so that it doesn't stick to the bottom. It is getting darker and darker. It's still a powder. The question is a new substance being formed, or is the copper changing color simply because it's a different temperature? Color changes can indicate a chemical reaction, but they don't always have to. There are some substances that will change color with temperature changes. So when you're making observation in a chemistry class, you want to get as much information as you can about the reaction, whether it's a physical reaction or a chemical reaction, in order to come to a conclusion. If it's just the copper changing color, then the mass should not be any different. If the mass increases, there would be an indication that something has been added. So the mass before was 49.42, and I'm just gonna get a current measurement. It's been heating for quite a while. It says 49.37, so it appears that the mass has gone down. I'm going to continue heating for a while and try to think of explanations that could make sense as to why the mass would go down. You see the contents of it are very black right now. And I'm still stirring so it doesn't stick to the bottom. If there was a chemical reaction, you have to think about what sort of reaction could possibly be taking place. I put pure copper atoms in there. But you have to remember that there's matter all around it. So it is surrounded by the air, which has which has 78 to 80% nitrogen in it. It has oxygen in it, has carbon dioxide in it. So in this heated environment, and even if it were not in a heated environment, if the element were exposed, it could potentially be having chemical interactions at the atomic level where those atoms are interacting. I'm going to get another mass and see if it has changed. It was 0.37 last time. It is going up to 0.41. So it went down for a bit. Peculiar. And now it's gone back up. I wonder if I can trust the scale. All of these thoughts are going through my mind as I think about this. I haven't gotten it up above its original mass. I wonder if I continue heating if it will ever eventually get above its original mass, which was 0.42. We'll take a little break and allow this to heat for quite some time and come back in a bit.
And we're recording.
Great. All right, we're back. I've been heating it for quite some time. I'd say maybe about 5 minutes or so, or 10 minutes, or maybe not even that. I'm getting eyeballs from my videographer here. If he can get a good view. I put him up a little higher so you'd be able to see the reaction.
Excuse me, but his safety glasses are not on his face correctly.
Well,
they're offering him no protection to his eyeballs.
Well, you know, he is an armadillo. He does need a name. Never named him. Just referred to him as my lab assistant. All right, let's get a mass and see if we've had any mass changes since it's been heating. The last mass was at, the first mass was at 0.42. Then it went down to 0.37. I think it went up a little bit after that, and it is now up to 49.49. So it is heavier. It's heavier than it was to begin with. So the only way that could possibly happen is if atoms have been added to the contents of this evaporating dish. And what you're seeing in front of you is a brand new substance that has been made, and the name of that substance is copper oxide. It's a black powder. I don't know if it's copper 1 oxide or copper 2 oxide. We could do confirmative tests to determine that with mass relationships. But that wasn't the nature of the scope of this because I don't know exactly what the mass of the original powder was. We're just looking at relative changes. So if you imagine me, I'm a copper atom, and I've been thrown into an evaporating dish, and it's getting hot, so my electrons are moving a little faster. It's getting really hot in here, and all of a sudden, under the right conditions, I can grab oxygens from the air. I'll have him be an oxygen, and we will stick together. And I hope it would make sense that if I was an initial mass and all of a sudden I have atoms attached to me, that product, that copper oxide, would make or would have a heavier mass, and it indeed does. So most students thought that the mass would get less because they were thinking the copper would burn and it turned black, and we're familiar with things that are burning turning black. So it is a bit of a surprise that it does indeed get heavier, it gains mass, but I hope that it makes sense that when the copper and the oxygen are bonded together to form a new compound, since it has taken those oxygen atoms from the air, that it would get heavier. This type of reaction is called a synthesis reaction, and it is a copper atom combined with an oxygen atom to produce a compound called copper oxide. So that is a conclusion for what students saw in this portion of the lab. We will be using this copper oxide in another reaction, and that'll be an upcoming installment. I hope that if you missed the lab that this will give you enough information for what students saw, and I hope that you enjoyed my lab assistant participating in this activity today. So have a good day. Thanks for watching. I'll see you next time. Okay, ready? I don't even know how to do this. Okay. So, you can start on me. It's warm. Is it recording? I don't even know how to start this.